Most of the innovations that has come about were started by little children. And our children are as bright or equally intelligent as these children, except that they have had the exposure. And I think if we give them the exposure, our children will also be innovative and be able to undertake a lot of inventions.
Children are doing well, even in the classroom, but when you ask a question that involves an application, it's difficult for the children to apply what they know. And that is because we have not been doing practicals enough, or we have not been teaching the subject based on activities.
There's emphasis on the senior secondary department. And so the basic school, the attention is not much. The laboratories and so on are not there. And the emphasis is on the theory more than the practical.
If the foundation is laid well for the children at the basic level, it will help them improve in their performance in science at the second cycle and then maybe the tertiary. If the child is taught the theory and he doesn't know how to demonstrate it or do it, it becomes difficult for the child to even remember some of the concepts.
We're not able to do practicals because, number one, we have constraint with time. There's constraint with teachers. How many science teachers do we have, especially that are teaching at the basic level?
My name is Anna Dosala Eresa. I am 5 years old.
My name is Enestina Ajim.
My name is Hananiel Ya Ashali.
Hello, my name is Natasha Tete.
My name is Mami Efwa Esamasam. I am in kindergarten too. The name of my school is Akosombo International School.
I've taught in 3 schools. One is in the village, that's Odobin Methodist School. And then the challenge I had there was, it's a village school, so there was no science lab. So we have to bring some of the equipment or the apparatus to the classroom. And there were some challenges that we had with because some of the chemicals were not around. So all that you have to do is to just teach the theory and then make sure the children pass and pass well, because at the end of it all, is the results that will count, not the information you give to them, whether they practice or not. So it was difficult teaching there.
We have come to discuss what we have learned in school with my cousin.
I can explain to you the life cycle of a maize plant.
What are those black things on the wall? They are our shadows. But how?
There's a purpose in the catch them young. And that science is all around us. Everything that we see is science. And science is life. And so we need to nurture them, to start from the scratch, so that they'll be able to identify science around as they walk about. Whatever they learn in the classroom must be practicalized.
I was very excited when they came to me that they were participating in such a project, because I've looked forward to seeing science being taught, moved from the classroom into the field.
We are exploring on ways of generating electricity using salt water, a lemon and a penny.
We are going to do an experiment on crystallization, which includes filtration and evaporation.
We are going to demonstrate how electricity travels through our home.
When the Scientifikids approached us as an institution to get us into this innovative idea of science teaching and learning, it was a welcome news for us at Kosovo International School. Why? Apart from the fact that we already have a very good scientific background for our students, where we try to engage them in teaching the science the way I'm talking of, the practical, activity-based one. This year happens to be a very special year for the school. Akosombo International School got established specifically on the 24th of September 1962. And since then, you would agree that we have clocked 50 50 years in the life of any institution is not an easy milestone. And so we really were looking for opportunities to celebrate the 50 years, the Golden Jubilee, in a very unique way. And Scientifikids has really offered us that opportunity. And you can just take it. We have to go for it. So we grabbed the opportunity.
Does oxygen support burning?
Where did you get this water from?
From the world.
That's the problem. So we have to blow it or shake it.
What else besides water and fuel can be used to generate electricity? How does electricity get to our homes?
All green plants have the capability to prepare their own food in the process of photosynthesis. The food they prepare is called glucose. Let's see some broad and narrow leaves around. Hi, this is a cocoyam leaf. It is a broad leaf. When we say a leaf is broad, it's not just in size, it's by the veins. The veins don't go in the same directions. They go in different directions. We call that network veins. Examples of broad leaves are cocoyam, pawpaw, cassava, and neem tree. What about this one? This is a maize plant. It's a narrow leaf. Narrow leaves have the same directions of veins. They are parallel to each other. Examples of narrow leaves are maize, ginger, pineapple, and plantain.
My name is Sylvia Emefasiangbe.
Samuel Baku.
We are going to do an experiment on crystallization, which includes filtration and evaporation. These are the apparatus needed: the measuring cylinder, the separating funnel, 2 beakers, and a filter paper.
And we have the spatula, the sand, and the salt. First of all, we mix the sand and salt in a beaker. And after that, we add a little water and stir it with the spatula. We stir it to dissolve the salt in the sand.
As we stir it, we are going to fold the filter paper into the size of the separating funnel.
After stirring, we need to wait for a while for it to settle down. Okay, as it has settled, we pour the solution into the filter paper, and this stage is known as the filtration. It's used to filter the sand so that the water, that's the salt solution, will drain into the cylinder. So as we pour it, we pour a little at a time and wait for about 10 minutes for the water to drain. As it is draining, we pour more water.
Even though the water here seems to be clear, but it's not good to drink because sand is from the ground.
Now, we have salt solution in the cylinder, and this is the sand. The separating funnel is used to filter out the sand. So now remove the sand, and afterwards, we pour the salt solution into the beaker. And after pouring it, that's where the evaporation process comes.
Our supervisor, Mr. Dosola, is going to help us light the Bunsen burner. Thank you very much, sir. Now we are going to put our beaker on the wire gas on the triple stand. So we put it on it. Because it is a slow process, you have to wait for it to evaporate before you can get your crystallization.
So as we wait for it to evaporate, let's talk about the industrial application. Salt industries use this method to filter out salt from seawater. As the Bunsen burner is heating the salt solution, it leaves solid crystals attached onto the beaker, and that's where we get the salt. Now from here, we see solid crystals forming, and it attaches itself onto the beaker. And please remember, anytime you're having your experiment, make sure your parents or your teacher is with you before you carry out the experiment. Thank you.
My name is Ernestina Ajim
Dimai Mate
and
Benjamin Asari.
Today we want to investigate whether really oxygen supports burn, and it's also about air. Air is a mixture of gases, and some of these gases are oxygen, carbon dioxide, and nitrogen. The materials needed are
a beaker, water, a stone block and matchstick,
a candle, and a glass jar.
First, you have your beaker. Then you pour your water inside. We must mark the level so that when it is rising, we will know that it has risen. Now let's see the level of the water.
It's 300 milliliters.
Then we light our candle. Bella, please take the stone blocks. Right now, we want to fix the candle with the stone block. Next, we drop the candle in the water. We apply our glass jar. So we cover it. Let's look at it. Let's observe it. As you can see, the water in the glass jar is increasing whilst the one in the beaker is decreasing. The flame is going off bit by bit and now it's gone off. It is because the oxygen that was kept in the glass jar has been used up, leaving carbon dioxide. The carbon dioxide has dissolved into the water to form carbonic acid, which the pressure in it has made the water rise and decrease. This experiment shows us that without oxygen, burning won't take place at all.
It's an opportunity to let the children feel science in the field, because science is real. It's not an abstract which should be taught in the classroom alone.
We have learned that light travels in a straight line. So when an object blocks the way of light, a shadow is formed.
This experiment shows us that without oxygen, burning won't take place at all.
The electromagnetic force is also used to lift light and heavy things.
You can also use salt water in textile industry for dyeing and tying.
The teacher can give his or her best if he's really motivated. If the teacher is really motivated, and if the teacher knows that this program is going to yield good results, the teacher will give his or her best. And I think if it is done during the vacation too, is good. Once the teacher knows that he's going to be motivated, he will give his best.
These scientific projects have not been very easy because everything is practical. It has helped the children and even those of us who are assisting them to come out with a project. But the time, we have to forgo a lot of things and programs to be able to do this.
We, the teacher, did not interfere with what the children were doing. We were just coaching them what they should do. But what they did, they brought the ideas. We learned some information from them. I got some information from the children based on what they knew, and then I added it to mine. So I really enjoyed the Scientifikids program.
We connected to our voltmeter.
What I realized was that the children get more of the understanding of what they have learned in the classroom as they practice it in the field. And they enjoy doing it because they are children and they want something that they can do than what they can hear. So they have enjoyed the Scientifikids program, and it has really helped them, and they have really learned a lot from it.
Akosomo is a very popular school in Ghana. And now that we've been introduced to this project, we feel very proud that we've been enlisted on this program, and we hope that it will yield results. And then from this, we'll have sponsorship, so we'll have it often for others who didn't get the opportunity to also enroll onto the project.
My students are really enjoying this period of Scientifikids innovative methods of teaching science, which they have taken the teachers and the pupils through. And I'm sure they themselves, in their own ways, may have given you testimonies of how well this program is going with them. The Scientifikids program is a program, and it should be replicated throughout the country.